Hey guys, welcome back. Mr. Will here. Video lesson for Every Day I'm Calculating for Thursday, May 28th, 2020. Got a little bit of a new location. I'm in the middle of your screen. That is so that we can see both problems here. So today we are back at it. We are continuing to talk about translation, reflection, and rotation. These are transformations when you have a shape that is moving from one place to another. Okay, so there's just different ways that we can talk about and describe these movements of these figures. So our question today says, look at the figures in the example. Describe what happens to the size, shape, and location of the figures when it's translated, reflected, or rotated. So here is an example of a translation. Okay. Um, and what that is when you have a shape, okay, this is a quadrilateral, and it's sliding over, and it still is a quadrilateral. It says every point of the figure moves the same distance in the same direction. So what happens to the size, shape, and location of the figure when it's translated? Well, the size and the shape stay the same, okay? It's the same size, same shape, but the figure is moved. If we look at the reflection, here you have this shape, the original shape in green. Here is the line of reflection, and it's flipped across the line of reflection. Okay, so again, what happens to the size and shape? It stays the same, but it is changing its location because it's going from one place, flipped to another. And then when we have a rotation, here we have the original, and the figure is turned clockwise on a center of rotation. Right here, this dot, it's kind of like when you play basketball and you have a pivot foot and you move on that pivot foot. Well, that's what's happening with this rotation. Here is the pivot. So again, it has the same size, same shape, but the location of the figure is changing. So the same answer for translated, reflected, and rotated can all be the same. Okay, the size and shape stay the same. Its location changes in all three. Okay, cool. Let's move on to the next question, which says the original green figure in the example has two right angles. Okay, so again, a right angle is when you have 90 degrees, right angle, and a pair of parallel lines. Again, parallel lines are lines that do not intersect. So there's the pair of parallel lines. So the translation, reflection, and rotations produce images that have those same properties. Well, let's look. Do you see two right angles and two parallel lines? Yes. So the answer would be yes, because they do not change in all three: translation, reflection, and rotation. They do not change size and shape, the figures, they don't. But they only change their location. So that's why they would have still your 90-degree angles here and here, and your parallel lines here and here. Okay, excellent. So they stay the same. Okay, what I would like you to do is I would like you to work on your practice and problem solving workbook. You are going to be using what we just talked about in the example with translated, reflected, and rotated figures to answer the questions on the next page. Work hard, ask questions. I'll see you back here tomorrow. Thanks.